My name's John. I'm from MongoDB. I've come here from Scotland today. It's nice to see you put on some lovely Scottish weather. I am using my voice because I have to speak to a few people today, so you're just going to have to read the slides, okay? I've got some bad news, which might thin the room out a little bit. This is it's a business presentation. It's got some technical bits in it. I'm 18 years as a developer up to a CTO in a NoSQL database company. So I am myself technical. But one of the things that people don't often talk enough about is money. And so I've introduced a few numbers in this with euro signs in front of them. That's money. And one of the key things is, please do not sue me if those numbers are wrong. You know, some I got from the sales guys, some I found online. They've been converted through a few currencies, including Turkish lira and back again. So they're all in the right kind of ballpark, but please don't sue me if it's wrong. So hands up if you know what MongoDB is. Okay, hands up if you don't be embarrassed. Well, I'm still going to tell you. Right, it's a general purpose database. That means that you can use it for a whole range of different things. The same kind of things you'd use a relational database for. It's not specialized towards any particular niche. There are things we're good at, there are things we're not quite so good at, but it's not that it's, Neo4j is a graph database, and there's some great use cases for graph databases. MongoDB is a little more general purpose. It's a document database. Simple version of that is it's not tables and columns. You take objects in your language, you store the objects in the database, you can index, find the objects based on their attributes, and perform operations on those. Welcome! You're late. And it's an open source database, but you knew that anyway. So, document-based dynamic schemas. What's this mean? It means we store documents in the database. I don't mean Word documents, I don't mean PDFs, I mean what we store are basically JSON documents that represent objects. The great thing is that you can store all different kinds of objects in the same database, in the same collection, which is what we call a table, which means you can evolve your software without having to go back and change the underlying schema or re-index or any of those things. So a typical example like this, employee name, department, you see their benefits are actually, it's kind of hard to see this, but their benefits are an array of objects as well. So rather than having to take the data structures in your application, break them down into flat rows, build relationships between them and store them all separately, you can actually just basically treat the objects as they are. Usability. The big thing in MongoDB is it's very, very usable. It's very easy to use. A couple of reasons. One, it's supported in a huge range of languages, and in all these languages, it works in a way that makes sense and is native for that language. So if you're working in Python, you're putting dictionaries and dictionaries with arrays in and out. If you're working in JavaScript, you're in the same ballpark. If you're working in C, you create a besom structure and add the correct bits. But it means that rather than having to learn a query language and a way of manipulating it, you just deal with the objects the way you would normally in your language. It also has a shell. So for those of you that have worked with other databases, one of the nice things that MongoDB has, and it's things that not all NoSQL databases have, is a shell where you can just go in and type commands, find, edit, update, exactly the same way you would from a SQL shell. It's got utility. So what do I mean by that? I mean, you can do quite complicated stuff very easily. Again, you take this for granted in a relational database, but it has complex indexed queries. So unlike a key value store, where basically you've got one field you can look things up on efficiently, or jumping through some real hoops if you want more than one, you create indexes in the same kind of way you would in the relational world. Okay, that field, that field, that field, in that order, indexed, please. And you can do aggregation in it, so you don't have to draw back to doing things like MapReduce. You can do, select, group, sum, average, all of those things. Okay, so in MongoDB, I can do a query like age is more than 65, and they're male, and they live near Leon. Didn't mention we also have geospatial query. And I can give me these buckets and age ranges and how much profit margin we're making on each one of them. See, I told you it was money there. And confession, I'm a techie. I'm also a techie who wants to be stupendously British. That's all. I know you guys are just in it for the coding, but I've got a wife now, I have to be stupendously rich for the coding. Scalability. So this is where we get into what makes a system scalable. What do we mean by scalable? Scalable can be there's lots of users. Not much data, but lots of users. It can be there's loads of data and almost no users. It could be both. It could merely be there's not that many data and there's not that many users, but if it goes down, the risk is absolutely enormous. So scalability covers a huge range of different things. And for that, we have high availability. So we have the ability to keep the system up and running regardless. We have auto-sharding. I'll talk a little bit more about that later, but that basically means I can add more kit when I get more people, users, whatever. We have enterprise monitoring. So we have the ability, when you have got the system, to professionally keep an eye on how it's doing, to make sure that your servers aren't going down, you're not running out of disk space, nothing's overloaded, it's all nicely balanced, and have the emails coming to you automatically at 2 o'clock in the morning, because there's nothing better than at 2 o'clock in the morning hearing the California data centers running down. And we have grid file storage, because we shouldn't forget the blobs. People like to store pictures. Okay, we can store pictures straight from MongoDB, but then people want to store movies. And suddenly it's, here's my 300 megabyte thing, please store it. So we just make that kind of easy for you. Grid file storage is effectively an API that's part of it. That says, store this 300 megabyte thing, and it splits it up into smaller objects and stores them, and then you can retrieve bits of. So none of this is rocket science, it's all good computer science. So my presentation is called Scaling Out as You Grow, and it's a story. I'm going to tell you a story, and you've got me on board. It's about these two guys. This is Tony, this is Andy. And I will forget those names, so feel free to remind me. Tony's the one with the short hair. And these two guys were computer science majors together. They were at university, they were best friends, and they worked together on their final year project. And their final year project, they were told to go away and start a web-based business, basically build an app, build a website, and they had a fantastic idea. What they thought was, what we need is a restaurant review site, because the world doesn't have enough restaurant review sites. But they did have a different idea. They said, what we need to do is go into the restaurant, I take out my phone, because the first thing I do in any restaurant is take out my phone and check it on Foursquare. The second thing I do is I check my email. Sometimes I might talk to the person I'm with, but most of it I'll be But what I want to do is I want to review the restaurant, not after the report. I want to review it when I go in the door. I want to review how I was greeted at the door. And in fact, I'm going to sit right through that meal, and every time something happens that makes me feel it's a bit better or a bit worse, I'm going to review it again. So they came up with this fabulous app. So basically it says you're in Luigi's Pizza, rate it 1 to 5. Now, by the way, feel free to take this idea. This is one of my spare.com ideas. So anybody that wants to turn this into an app and make a fortune, this is an open source idea. And so we produce a graph like this. 10 minutes into the meal it's a 4, but 20 minutes in, when I've actually served some food, we're up at 5. But then it kind of drops away 40 minutes in because we want dessert moving through the table. And it would record all of these things. And he had a business plan as well, money again. These guys said, what we do is, of all of this, but we charge the restaurant owners to get lifetime information from this. So if the mood in their restaurant is dropping and everybody's giving lower and lower results, we'll tell them immediately. And we'll give them the ability to go in and look at more detail. So the general public can say, yeah, tonight that restaurant's not looking so good, but I'll have a look at the week, and generally, a meal's good towards the end. But more importantly, the restaurant owners can go in there and for a small subscription every year, get lifetime feedback on what people are saying. It's kind of like people just tweeting about restaurants. You're not going to tweet 20 times during the meal about food unless you're my ex-girlfriend. Obviously the conversation wasn't really. And even better, it was a good project. They both got A+ marks, and they won the university's €10,000 award to take it and turn it into a real business. And if that sounds crazy, several of the UK universities do this. Top project, it's a big pile of cash to go and turn it into a business. That's where all went horribly wrong. The university had them write this on Oracle, because they had Oracle, they taught them relational databases, so they built the system on Oracle. Tony said, great, let's launch. And he said, no, let's not launch on Oracle. I've written in Oracle, I've written it in Java, I'm not happy. Why don't we rewrite it on the MongoDB? And we were rewriting on MongoDB and maybe with Node or something like that. So they had a bit of a falling out, they had a few beers, they had a big falling out, and eventually we split cash. So Tony took €5,000 and launched his site. He went ahead, bought a domain, he bought mealtime.com, leased the server, installed Oracle XE because it doesn't cost anything, and launched it. So he's built Box, Oracle Database Enterprise Express Edition, 1 CPU, it's quad-core Box, but unfortunately XE is only going to use one of those CPUs, but hey, we've got quad-core Box, 2 gig of RAM, spent $300. So he got a mealtime domain and he spent, you know, maybe $270 on leasing the machine for him. And he decided to go for a rewrite. He spent $30 and bought eatwhen.com, downloaded MongoDB and started rebuilding. Okay, here comes the science. A little bit about MongoDB. It's a relational schema, it's got lots of tables. What you do is you flatten them all down, you take this entries for this table, put them here, you end up with documents that describe that. So basically, you take a lot of tables and you say, well, what we were doing is we had these objects, we flatten them all down to tables. That's not what we're going to do, we're just going to take the objects as they are, with the arrays of objects inside them, and put them in MongoDB. Why do you do that? A couple of reasons. One, it means that all of the data, when I want to retrieve, say, a restaurant review, is all together on the disk and in the database. I don't have to hit all these different tables. So when retrieving something, you might hit a bunch of different places in a relational database. MongoDB, they're all together. Why is that good? Because to get the head on the disk to the right place, or SSDs later, takes a lot of doing. So you don't want to do it lots, you want to do it once and then read all the data. Good analogy for that, I just don't have time to do that right now. It gives you good in-memory caching. So operating systems are great at mapping stuff in and caching it in memory. I read this data, caches it in memory. The thing is, they do it in chunks, 4K or 8K chunks, depending on your OS. So if you read 100 bytes here, it's going to cache 8K around that. It's going to cache this 4K things. So really, I want to be using all of that 4K because I've got that cached. If I've got 100 bytes all over the place, not so good. And it also gives you the ability to do in-place updates. So basically, without moving data around, I can go in there and change it in situ. So a month has passed at mealtime.com. Remember, this is our Oracle site, and he's doing well. I admit it's a cracking idea. So, 20,000 users, 150,000 reviews, 900 restaurants. He's got an enormous 38 megabytes of data at this point. He's no idea where he's going to put it all, and he's got 2 customers. Well, Tony's got 2 customers, not Andy. Tony's got 2 customers who've paid him €20 each. Doesn't seem much, but hey, it's proved the concept. Somebody's prepared to pay for this. He's still only spent $300. He's still running on a machine with 1 CPU and 2 gig of RAM. Sounding good to me, a month in, and he's got customers, and he's, more importantly, 20,000 users is a reasonable number. Meanwhile, eatwhen.com, well, he's finished the code, because it's actually, seriously, really quite easy to build things on MongoDB. He's leased the server, and he's launched, bought a bit bigger server. He'd heard from someone MongoDB needed a bit more horsepower. Not strictly true, but it's how people talk about it. But so he's got 20 CPUs, got 4 gig of RAM, but at least he's using all of them. So, a couple more months pass. What's happening in mealtime.com? Well, mealtime.com is doing pretty well. He's got 250,000 users. He's got 9 million reviews. He's got 15,000 restaurants, and he's got 1.3 gigabytes of data. And more importantly, he's got 200 customers, all of whom have given him €20. So he's looking at €4,000 profit here. Now, this is good. Only with a bit of a problem here. We've got 1.3 gigabytes of data in 3 months. It's growing kind of exponentially, and Oracle XE has a nasty little habit of not letting you put more than 4 gigabytes of data in a database. That's the design. It's free as long as you want less than 4 gig. So that's okay. They've got a thing called Standard Edition 1. It's kind of one step up. It's the gateway drug to actually paying for it. And for his 1 CPU, it's only costing him $3,925. We charge for it by actual physical chip. So that's fine. He's made $4,000, spending 3,000 euros, 3,900 euros, 75 euros profit, that's enough for the pizza. At eatwen.com, this guy's still playing catch up. The good thing is he came along second, and there's some people who always like to choose the second one, because you know it's only the hipsters are still on the first one. So he's now got 25,000 users, 250,000 reviews, 100 restaurants, 80 meg of data. As I said, the data's a little bit bigger in MongoDB. Certainly until you start doing some clever things, it's going to be a little bit bigger than your relational database. And he's got 4 customers, so he's also, you know, $75, $80. He's happy. And it just kind of chums along. Okay, 6 months after that, and they're still growing. Both businesses are being successful. We're competing wildly. I don't know whether there are 2 camps of people who like one or the other, or everybody just likes to review on both, because there's nothing else to do during a meal. So, 500,000 users, 27 million reviews, 35,000 restaurants. Now, 27 million reviews to me seems like quite a big number. To be honest, that does seem like that's a lot of people who press buttons. But ultimately, that's only 4 gig of data. And he's had 1,500 people give him 20 euros, which is 30,000 euros. Okay, this is a business. I've had 30,000 euros in my first 10 months, or thereabouts. That's a business, I like that. What I did have to do was get a bit more CPU power, because I was starting to struggle with Oracle, and I wasn't getting the throughput I wanted. So I've actually upgraded to the same size box here that we had the MongoDB system. Unfortunately, Big Red didn't like that and came along and slapped us with another 3,900 for the other CPU, plus the cost of the server. So he's now spent 8,100. I think we've taken 30,000 to spend 8,100 because I could do with the MongoDB, well, we're still on the same old server, and hey, we caught up. So we're now running the same amount of data on the same server. That's good. And all was good until they had some problems. They added some new features, a few things broke, wasn't working the way they wanted. And they both went, hell, we haven't paid for any support on this stuff. So Tony got in touch with Oracle, and Andy got in touch with MongoDB, and they dug in their pockets, and we bought some support. And guess what, the Oracle support was cheaper, because it cost 750 euros per CPU, and you bought 2 CPUs worth. The MongoDB support cost them 4,000 euros. That was the kind of mid-range MongoDB support. And then so they bought their support and they went with their problems. And you know what worked for Oracle? Anyone going to report me for libel? So they bought the Oracle support and they complained to Oracle, and Oracle said, good, we can sell you some consultancy to fix that. And they bought the MongoDB support and they got some help and some assistance. And it's a great thing. I'm telling you now about MongoDB subscriptions. There's a help desk. It's not a help desk because you've got a bug. It's not there because your system's crashed and it's lost all your data, because it doesn't do that. It's there because you're not happy you're making as much progress with your application, your business as you want. So even if you haven't bought a subscription, you can raise tickets against MongoDB, and they can be, how can I make this go a little bit faster? I'm doing this. It's the classic thing. You all know if you ask a question in IT, the way you do it, you say, I've tried this, 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 and this. I've done this. Can I do any better? That's much better than how do I do this? But I'll tell you now, if you raise a ticket tomorrow, somebody will help you. If you've got paid subscription, they'll help you faster. It's as simple as that. So right now, we've actually had to spend some money with MongoDB, so that's 4,000 euros. It's still not quite as much as we spent with Big Red. And they've also thought, we're taking money here, you know, $30,000, what happens if it goes down? We don't like risks. We need high availability. We need this system to be up. It needs to be a cold day in hell before the system doesn't work anymore. So mealtime.com do a bit of research and realize that they're going to need Oracle back. Oracle real application clusters is the only way they're going to get high availability. Okay, they don't get that with standard 1, so they're going to have to move up to standard edition. It's complicated naming. Standard 1, entrance level, standard for ones above 1. So it's not standard 1, standard 2. And to use that, they're also going to have to put stuff on SAN storage. Well, that's okay. These guys are kind of cloud hosting, and let's assume they can just get their hands on the hardware they want. So they've got some shared storage and a second server. And Oracle, of course, charge a little bit more for this. They're still charging by the CPU, but we've upped the box. So now we've got 4 cores, and we're paying 13,000 euros each for them, plus hey, we found a very, very cheap SAN, and we're paying a couple of grand a year for it. But at this point, they've got high availability, honest, and they've spent 65,000 euros. Now let me talk to you. High availability, MongoDB. We like that. It's important to a lot of our customers. The system is up. So MongoDB has a system of replication and failover. Basically, you set up multiple machines, minimum of 3, and you write to one machine. The other machine mirrors the changes. You can choose whether or not it does those kind of after you've committed it or before it admits that it's committed it. So you can have synchronous or asynchronous replication. We support multiple data centers. These are the things, coming late to the database market or early to the NoSQL database market. It means little things like being able to have the replication work properly between 2 data centers come to us fairly easily. We don't have to have that shared storage in the middle. The other thing about having the 3 is it does make for kind of improved simplicity. You can actually take a node down, upgrade the software, bring it back up again, and work your way around them. So you can do upgrades of the software without taking it down. And it also gives you durability and consistency in data. If somebody wants to come after this and have the whole conversation with me about what's consistent, what's durable, and what isn't, I will take great pleasure in ripping the hell out of it. But these guys really don't like risks. So the MongoDB guys said, yeah, that's great, you've got 2 servers, but if your data center catches fire, falls over, it happens. Happened in Ireland, happened near London with an oil terminal caught fire, you're in trouble. What they did is they bought 2 more servers, or at least 2 more servers, in 2 more data centers, and they paid MongoDB for 2 more subscriptions to buy the server. So they've now shelled out a total of 13,830, but they can have network links go down. Somebody bomb Paris. Somebody bomb Paris. Any of these things, and their system will keep working. And it grows. So, they're doing well here. Now they've got 5 million users. Does this sound ridiculous, 5 million users? I don't think so. Not in today's software markets where, we generally don't charge users anyway, so you get massive numbers of users. Think about this, it doesn't cost the users a penny. It's amazing how many people will get involved in something that doesn't cost anything. Have you seen the crowds out there? We've got 900 million reviews. They're in 350,000 cafes. It says cafes there because restaurants doesn't fit. And they've got 600 gigabytes of data. So basically, since we last saw these guys, they've grown 10 times. So what do? They have to scale up the hardware. So they scale up the hardware, and they go to their data center provider, and the Oracle guys have said, I need one of your big servers, I need one of your the biggest thing you've got. They're actually based on the biggest thing that Amazon have got available as a cloud host. Because quite frankly, if it ain't fitting on that, they've got real problems. Because you can't go any bigger, it's the biggest thing available. But in order to run on that box, Oracle's going to make a move again to Enterprise Edition. And here's the kicker, on Enterprise Edition you don't charge by the chip, they charge by the CPU core. And they charge, for basic cluster replication, they charge $65,000 or so per CPU core. So I want to talk to you about numbers, because I actually like numbers when they're that big. Really. So the licensing costs, and obviously you can get an Oracle salesman and stand and bend his arm and tell him he's not making his quota, and he will give you a discount. I have to be fair, Oracle will discount these, but not that much. 1.9 million for Oracle Enterprise at this point. When he's going to be, big, but not Facebook big, not Foursquare big. MongoDB takes a different approach, and you'll have heard this already today, no doubt, but we have sharding. More importantly, it took me a long time to understand the difference. We have auto-sharding. So, it's not that hard to actually, just start up lots of databases and run against them. But there's a lot of knocking about, and a lot of thinking, and then there's a lot of things you can't do because you split them over multiple databases. Especially if that's a relational system, because now I can't join between these things, and so on, stuffed. Basically, sharding doesn't work nicely with relational argument. So we have optional sharding. What that does is it basically says, I can tell it this is a sharded system, I can tell it that this particular value is the one it should use for working out where to store that data. It's a range of values, so names A to B go on that machine, names C to D go on that machine, and so on. But I don't need to tell it that, I just need to tell it name is the thing to split it up by. And the system will then automatically balance the load across the data. If you get lots and lots of names starting with J, it will then start to move the J's onto more machines. So the key thing with MongoDB is it's not just sharding, it's automatic sharding. It's actually really, really easy to set up and use. If anyone wants the real trick, one of our senior guys showed me a single line command in MongoDB to set up 2 shards and a router. Just type it and it's up and running. It's great for testing. It means that you can run the system without having to move to big hardware. So you can stick to that original 2-socket, 8-core box that we had and just add more of them. Now, I come from an enterprise background and I've seen what happens to the prices of servers as you try and buy ones, it's like 8 cores is easy, 16 cores isn't so bad. You try buying 64-core boxes with 2 terabytes of RAM, scary money. It's not 12 times what the original was. So you can scale out on commodity, sensible size servers. The sweet spot for MongoDB is about $10,000. If you were actually buying the hardware, which very few people do these days, don't buy a $20,000 server, don't buy a $100,000 server, buy multiple $10,000 servers. That's the best bang for that. And it gives you kind of overall cost visibility as well. As you grow the business, you can just plug in more hardware. You don't have to go out and buy a big box which starts depreciating, losing value, and basically you might have spent, I've seen people spend $500,000 on that server. So after 3 years the business continues to worth nothing. Needless to say, they wouldn't give it to you to take over the weight on it, but that's what the accountants say is that money is how does that play with the replications? We talked about replication earlier. Simple, each one of those shards exists in each of our 3 data centers, and so each shard has high availability. And how do we use it? Application and driver, they kind of go together, so MongoDB bound with bits in whatever language you're working that they're out to talk to MongoDB. It then talks to something called query router. So the query router gets an incoming query and goes, okay, actually, I don't need all the shards to deal with this one because you're asking about a particular thing, and I know the information on that particular thing is on that one, so it will route that query off to that shard. If you do a query that has to hit all the shards, or some of the shards, it can do it. Yeah, it's like database partitioning, just done across multiple machines. So what's our architecture look like if we scale out? Well, they basically went and bought 3 more servers for each of their data centers. So they've got the same volumes. We're talking 600 gigabytes of data. Now, again, feel free to come and talk to me afterwards about what's big data and what isn't big data. A Boeing 747 generates about 40 gig of data as it flies across the Atlantic, reading things at, I think, every 2 milliseconds from about 6,000 sensors. That's big data. 40 gig is big data, when actually it's 2,000 different variables and X many thousand different readings and you need to make sense of it. My throwaway for today, big data is any data where a traditional data management technique doesn't work for it. Anything where it's not easy to just go, yeah, I'll just do this one. You have to think about how you're going to process your data. It's big. They move up to the enterprise version of MongoDB. Just pause. The enterprise version gives you a few things. It gives you access to the training immediately. So instead of having to do a 6-week or 7-week online course, you bring developers in to access the training. We have something I'll talk about in a minute. Actually, I think I'll cover these, so I'm going to skip that a bit. So we move up to the enterprise version. We run 9 more servers. Our spend is now $100,000. Okay, so Oracle, same position, 1.9 million. MongoDB, 95,000. Yeah, there's some money here. So let's review that. Yeah, as I said, Oracle Enterprise, it's got 2 servers, they each have 32 cores. It's got SAN storage, it's got high availability in the data center. They've spent $1.9 million today, and they're paying $390,000 for it. MongoDB doing the same job. It's got 12 servers, so if having lots of servers freaks you out, uses local storage. The high availability works between the data centers, so you can lose a whole data center. We spent $30 because we had to buy the domain name, and every year we're giving MongoDB 81,600 as a subscription, which is support a few other things. So what if you want to add some kind of analytics to this? What if you want to say, well, that's my live system, but I need some data off on a number crunching box, a data warehouse, or a cube, or whatever you want to call it. I want the data basically, I don't want to do the big maths on the live system. You can have that in Oracle as long as you add to data guard. That's another 262,000 plus the cost of the servers. MongoDB, yeah, you're going to have to buy the server still, but that ability to replicate it out to a server that's just kind of read-only for the purposes of analytics is built in. And that's built in not just with the enterprise version, but with all versions. What about keeping it up and running and making it run quickly? Well, yeah, Oracle will charge you €4,000 per core for the diagnostic pack, and €4,000 per core for the tuning pack, and they will do trading for euros. So, leaving the trading aside, that's another $250,000 because you wanted your system to go a bit quicker on the same kit. MongoDB with Enterprise, all the trading you want is included, all the monitoring is included. So we have a thing called Mongo Monitoring Service, which is an online service. The online version of it is available to everybody right now. You start up a MongoDB instance, point this thing at it, gives you nice graphs, charts, alerts, sends you emails, tells you when your page faults have gone above a certain level. All the great stuff that you get in the diagnostic and tuning packs from Oracle. It's free if you want to host it yourself, because you don't want to actually be pushing this information on your multi-million-dollar system out to a cloud-based system that MongoDB will run. Then it's included in MongoDB Enterprise. And all the tools you need for tuning, great selection of tools to tell you what's going on, they're all free as well. So, I managed to get through this a lot quicker than short version is MongoDB can save you a lot of money. Whether you're an existing enterprise who currently have Oracle, Exadata, a lot of people are taking mainframes now and pulling the data off the mainframes to use for new purposes. So they're still running their old systems with the mainframe, but they're not trying to build new ones. A bit of a short of the COBOL program, the kids today. So MongoDB can save you a lot of money. Well, the commodity servers, there's no need to buy big iron, as they call it. You think it's a coincidence that Oracle bought Sun? People say it was for Java. Big machine. Internal storage, so you're not paying for SAN storage. Those of you that have paid for SAN storage know that that's another way of really making you hurt. Those of you that have paid for serious SAN storage from cloud providers will also do that. It lets you scale out, not up. Same thing, basically. Small boxes, parallelize the job. Parallelize the job and get it done without building the big kit. And no upfront license costs. Basically, when it's working for you, we say, could you pay us for some support, help, give you a few extra things, but we're not going to charge you regardless of how big your business gets to actually get up and running. And you can see the costs growing because you're growing it incrementally. Company's called MongoDB. I'm John Page, and I'm actually open for questions. It's a lot of silence.
Sorry, actually, when you were talking about Photoshop, you have also mentioned that it has to be replicated through the other servers, I guess. Is it mandatory, or can we just distribute data between shards at that time?
So, are you asking, can you have 3 machines which are also shards of each other?
Yeah.
So I asked exactly the same question as part of my basic training. And the answer is, it's kind of, technically you could, but then each shard is also having to do the work of 3 shards, because it's having to do its own work, plus replicating this, plus replicating this. So unless you have a very, very read heavy workload, it doesn't make any sense to do that, because you're actually having to put in bigger boxes to do that, and you just don't get the scale out that you expect. Does that make sense? Basically, you don't get anything for nothing. So technically, you can set it up like that, but then you'll end up having to add more shards anyway. Replication is required. So you need replication sharding are two different things. You do need really 3 machines for replication. Shards. You get involved with MongoDB, a couple of bits of advice on shards. Shards are A, they're one of the killer features. B, don't assume you need 2 machines for sharding. If you have a machine with 4 CPUs, put 4 shards on it, you will get better throughput. Shard on 1 machine, shard early. The other thing about doing that is if you build from day 1 with shards, when you do want to add another machine, you don't have any thinking about it to do. You're just plugging the machine, it's already used to it. 4 on here, pick up 4 more on here. I built something and then I went to sharding. So shards, my advice to you is always, shard early. Think about it from day 1.
Is MongoDB support transactions as well, like banking or applications?
So it's used for a number of cases. It's used in banking and telecommunications. It's not used for traditional banking accountancy applications. So MongoDB only provides the ability to update one piece of information, one document at a time. So it can do an atomic find and set. It can say this document, if this is true about it, change this. What it can't do is promise to change 2 documents or not change 2 documents. There are some workarounds if you really have to do that. But if that's your model and you can't get around that, then it's not the right thing to use. In banking, it's being used for ticketing cases. It's being used for, as I say, offline. People are taking the mainframe data, pushing it into MongoDB, and then using that to provide new services like mobile services and advice, rebalance and getting load kind of things. Telecoms data, again, a lot of the telecom services around personalized information are being done with MongoDB. There are some people starting to use it for classic telecom delivery. We're working through that. I don't think there's anybody live using it for telecom line translation.
I worked in a company where the network between different offices and regions availability. So in terms of application and distribution, how does MongoDB compare to Oracle?
So in terms of how the replication works, and how you can deal with a sort of limited data, you obviously have to be able to get the data from A to over there. That's kind of given. So if you're writing more here than your network can, including the fact that you can put compression on. So the way MongoDB replication works is actually it makes TCP connections to the same thing clients do. It's very open. We're very open about how all of these things work. So assuming that with whatever compression you choose to layer on top, you can get it over the network, there's no need for synchronous transactions. Things our customers have found is that replication, the example they gave with SQL Server, was that they had to write it here, and you didn't get a response back to the user until it got over there and got back again, which was just too high a latency. So MongoDB has the ability to kind of batch that and pull it asynchronously from replication, which means that you can make much better use of compression, kind of higher latency and lower bandwidth.
Comparable with Oracle?
It's comparable with DataGuard. It's comparable with DataGuard if you're doing that. But DataGuard doesn't give you high availability failover. DataGuard you have to actually go and fiddle with it to get it to come on the other side, which you did last time I checked. So it's more technically more comparable with RAC, but you're right, the transaction streaming is more limited. And in fact, all of the same write concerns exist in DataGuard and exist in MongoDB. Please write it only, let's say the journal, please write it, we'll keep it in RAM, please write it in the journal, and commit to the user file.
Do you decide or the company decides where to project
Wherever you choose to don't care where you put your servers. You can have, some organizations have their own data centers. It doesn't make any difference to us. I mean, we have offices in Sydney, Los Angeles, New York, London, Israel. So, but where our offices and where our business is, it doesn't matter where you choose to host your data. The only thing I would advise is to follow the standard rules, make sure that each of the data centers is at least the last 12 miles apart. And in fact, given the geology around here, we might want to make it a little bit further for some office.
Where does
So AWS and Amazon themselves are one of the partner. They provide support on setups as to Google Web Services. So MongoDB tends to be richer than the offerings they have, and it has actually a lot more people use it, a lot bigger community. We are the #1 most of technology at the moment. The way we measure that is we have various companies out there that look at job postings, at LinkedIn profiles. Basically, it's much easier to find somebody who can and wants to work on MongoDB than it is who wants to work on Amazon. Okay, questions back? Conscious of time, probably the last question.
Yeah. Yep.
Yep.
You made comparisons between MongoDB and Oracle. What if the real-time site was using a same relational database solution like PostgreSQL or MariaDB or Falcon or something like that?
So MariaDB and PostgreSQL, they're both good and certainly evolving relational database systems, especially Postgres. Where they lack is the sharding is the concept, so the ability to scale out, which is the idea of this talk. It's much harder in a relational database because there's an expectation you're going to do joins, and doing joins across shards is near enough impossible. Actually, the founders of MongoDB had built DoubleClick on top of those kind of technologies and found that caused enough problems that they then went ahead and built this. The same in terms of high availability. Last I checked, the high availability systems available for Postgres and MariaDB weren't nearly as robust and sort of full-featured as the ones from MongoDB. So they're good technologies. They're certainly, I'd choose them over Oracle if I was going for a relational model. The guy that built this on Oracle is not. And finally, you have to look carefully at what your support organization is. In all of these things, it comes down to, if you're going to have a business that's going to be bringing in $300,000 every 6 months, you really want to make sure there's a company backing you up. This talk is about when you are hugely successful, what you're going to do. When you've only got 50 users, you saw, or you've got 100 users, or you've got 1 million users, you don't necessarily need to spend the money. Thank you very much. My name is John.